Okay. There's an interesting thing, and it's grouped in with our properties, and it's something that we teach very early on. We want students to understand, but that's the identity. And the identity property breaks out into the addition and the multiplication. Okay? So the addition property is not 0. The addition identity is 0. Okay? The property is more than just a singular number. Okay? So this, we often think about 0. Okay? That is the actual additive identity. When we put 0 and something else together with addition and subtraction, okay, it doesn't change its value. It doesn't change what it's representing. Okay? And that's important for us to know and be able to use in our thinking. Okay? One of the other aspects about the addition property is how do we get to the identity? Okay? Getting to the identity, a lot of times the discussion about opposites comes up. Okay? So this opposites is an interesting setup because when you think about like 3 and -3, and we haven't really talked about those numbers a whole lot, but if I take a number and subtract itself, then I'm going to get to 0, right? So that's how we're getting this relationship, and these are called opposites with each other, okay? One being positive, one being negative, okay? 0 is actually our end goal when we're doing algebraic work, okay? But we're going to talk about it and teach it early on in all of our thinking and systems, okay? So if I have something like x plus 4 equals 9, okay? How do I go about solving this? I know in your mind, you look at that, you instantly know the answer, okay? But what are we actually doing? What is the process that we're walking through, okay? I want this to actually be x plus 0 equals something, okay? Because plus 0, I don't need to write that anymore. So in order to get plus 4 to become 0, I minus 4, right? There's my opposite value. Then we get into a little bit here about the importance and integrity of the equal sign and what it represents and what it does. We'll talk a little bit more about that in a different video, okay? So here, we're actually going to zero these out, and it's always nice as a teacher that I do particular note-taking, okay? So I like to write that 0 over top of those so that way they recognize where 0 is being used. I got to a 0, x plus 0, okay? Now, because of the equal sign, I got to do the same thing on both sides. So I minus 4, so 9 minus 4, so I get x equals 5. That's my end result, okay? So this addition identity is an important thing to know and understand because we're going to use it all the time, okay? When it comes to algebra and solving and being able to get things, we don't want that there anymore. Well, how can we cancel things out? How can we move things to the other side of the equal sign? All of that is done through this identity property, okay? Now the multiplication and division, okay, identity is 1. And I do want to just take a second because we call it the additive identity or the multiplicative identity, okay? But it works because anything minus 0 doesn't change its value. This, because of the commutative property, I can do 0 plus anything or anything plus 0, right? So that's how it's written out. Plus 0 equals a, right? It can be subtraction as well if it comes second. And so that's why we don't call it a subtractive identity. We call it the additive identity so that way the order doesn't matter. Because we have to kind of compartmentalize and say, this is the overall principle, And then in a different situation, you're going to take that property and apply it in a few different ways, okay? So the multiplicative identity is 1. The multiplicative identity property is that A times by 1 equals A, okay? And this works for division as long as we're dividing by 1. 1 divided by something is not going to come out the same, okay? Anything divided by 1 would be the same. 1 times, or anything times 1 comes out the same, okay? Now, this idea and the many ways that 1 gets represented is huge, and a lot of people have no idea about it, okay? So, the different ways that 1 shows up, it is a master of disguise. We do a lot of things with 1 and we never even know what's going on, okay? We learned a bunch of things that our teacher said, this is what you do, and that's your answer. And we have no idea why that works. A lot of times, it's going to be one of these two identities. A lot of times, the multiplicative identity, okay? So, with this, that idea is huge. So one of the big places that we're going to use it, we'll talk just a little bit now, and you'll get more about it in our numbers, is about fractions, okay? If I have something like 27 over 36, okay? One of the first things that we have to do with this is reduce, right? Reduce, simplify, all the time after you're introduced to these numbers, always get it in its simplest form, okay? How do I do that? Well, I have to divide the top and bottom by the same value, okay? So I need something that has x over x. Well, something the same on top as on bottom is 1. So here, what am I actually doing? I'm going to do the multiplicative identity and divide by it. So it doesn't change its value, it just changes how it looks, okay? So in here I can divide by 9 on top and 9 on bottom. Both of these are divisible by 9, and I get 3/4, okay? Now, the connection that a lot of us never even think about is 27 over 36 is the exact same value as 3/4, okay? I use a 1. And this is something that, again, like writing that 0 over there, writing the 1 in here, or a super 1, as I've seen it called in textbooks, is really helpful so that way we can all see what's going on with them. Okay? So changing values, or changing how values appear, is a big part of using the multiplicative identity. Okay? Just like when we have 4x equals 24. How do we solve this? Okay, we want the same thing on top as on bottom. So we divide this by 4. And we have to do the same things to both sides with the equal sign. Here I now have 1x. I don't have to write a 1 next to all my x's, it's just x. And that's my goal, is to get x all by itself. It's really not. Has a whole bunch of zeros and ones all around it doing different things, but it's the identity, so we don't have to write them anymore, okay? So that's how I get these things and can actually solve out algebraic problems, okay? So I want to go into another example about the multiplicative identity, and especially where we use it. When I have something like 3/4 plus 2/3, okay? Adding fractions, what a pain in the butt, right? Because you have to make the same denominator. The whole process of this is actually just using the multiplicative identity. Not that it makes it any easier for us, but actually knowing why and how it works, okay? I'm going to rewrite each one of these as a fraction of the same value by multiplying it by 1. By the multiplicative identity, okay? So, we'll talk a little bit later about finding a common denominator. We're all very familiar with it. I want these to equal fractions with a denominator of 12, right? So I've got to get fractions in here, and it's going to be different for each one of them. How do I get 4 to become 12? Well, I times it by 3 over 3. What does 3 over 3 equal? 1, multiplicative identity, right? So I get this end result, and I do all this work, same on top as on bottom. That's the rule that we tell students over and over, and they have no idea that the reason why is so that way we're multiplying by 1. We're really taking all of this and multiplying by 1, okay? And that's how we're getting there. So we aren't changing its value, we're changing how it looks, okay? And I say all the time, this is me when I came home from work, okay? My wife says, we're going out tonight, would you go shower? I have to go shower and take care of all of me, and then I look like she wants me to, and she'll now take me out, okay? Understanding that, I didn't change as a person. She's still taking the same person. I just finally look appropriate for going out with my wife, okay? And that's important things to understand here. This is not a friendly form for this problem. This is. Using the identity helps us to get it into a form that is more user-friendly for our students to see and understand, okay? So we're going to do a similar process down here. It's 4 over 4. All right, 3 times 4 is 12. I'm going to do 8. Okay? So now these two fractions, the exact two values I started with, are now in a way that they can be done and dealt with in this problem. Okay? And so that's an important thing for students to be able to do and understand and be comfortable with. So that's what the whole purpose of having these identities are. We're going to see them start to come up in different ways throughout all of our algebraic and numerical work. And we're going to see that, and we as teachers always know what's going on. Our students don't always know. Sometimes we can take the time and explain and discuss with it. Other times they aren't ready yet. Okay? But as soon as they are and are starting to ask them those questions, don't be afraid to tell them what's going on. Okay? That this is really a special number 1, and that number 1 doesn't change its value at all. Okay? Now, opposites, as we talked a little bit about here, with the additive identity, aren't real difficult to do. Okay? But in order to get a number like 3/7, how do I get this to become 1? Okay? This is where the idea of a reciprocal comes in. And we want this to end result equal 1, right? But that's going to equal some fraction. The fraction that I multiply this by, its opposite, okay? Which is, opposite's kind of a funny term in that because it's not really an opposite. We call it here a reciprocal. Okay? That reciprocal is really just this thing flipped over, okay? And that's the simplest way to be able to be thinking about it. Because I want to get the same number on top as I do on bottom, okay? And doing that, this is the simplest form of it, is just flipping that fraction. Now I'm going to get 21 on top and 21 on bottom. That equals 1, all right? Does it have to be those numbers? It does not, but the value will always be equal to that, right? So if I had 3/7, okay, and I did that by 14/6. Now, like, where did you even get that? I'll tell you in a second, okay? Is this a reciprocal? It is, but it's not the reciprocal, okay? And that's kind of an interesting thing, because this is a right answer. Is it the best answer? No, that's simpler, okay? Now, if I actually look at these two fractions, all I did was times the top and bottom by 2, right? Use the multiplicative identity to create this new fraction, which is more complex, right? Just timesing it by 2. What do I get on the top? 42. What do I get on the bottom? 42. Okay? That still equals 1. 42/42 equals 1. So this works as a reciprocal, but it's not the best answer for us. That's why we just do this one and keep things simple, because it's the same numbers. I can see how those two relate. Here it's getting muddy, okay? Mathematics, the simpler, the cleaner that we can do it, the better, and we try and do that. Sometimes it's almost too clean. We muddy things up in our mind, and we just have a hard time even seeing what that can be for us. So when I did this, all I did was multiply by 2. But being able to see that each of these was multiplied by 2 takes more thinking, so we try and do it in the simplest way.